So today we are going to be looking at chapter 5, Forms and Radicals, because by popular demand you didn't want to write your test today, so we'll start with chapter 5.1, evaluating powers containing rational exponents. Okay guys, when we have something like x cubed, how in our simplest form can we write that out? X times x times x. Right. When we have something to the power of 0, what does that mean? That's 1. Anything raised to the power of 0 is just 1. And what is x to the negative 3 mean? No. 1 over x, right? This is cubed. When we have something raised to a negative power, it becomes that, which is the same thing as 1 over x times 1 over x times 1 over x. Alright, what about the word rational? What does that mean? We've only seen it about 1,000 times, right? Rational just means fraction. What do you think rational exponent means? Fraction and the exponent, right? So I don't think you guys have ever dealt with stuff with fractions and exponents, have you? First, that's going to be stuff like x to the 1/2. 2 times x to the 3/4. We'll be looking at stuff like that. This is just an example. We'll get to how to solve these. Okay. So we have a couple formulas here. No? X to the 1 over n equals the nth root of x. There's a whole big proof, but I don't really feel like showing you guys. Also, if we have a number x raised to the power of m over n, do we have something on top of our fraction? Like a 3 over 4 or a 2 over 3? That is equal to the nth root of x to the m. See a couple examples here. Oh, that's not so bad. The thing to notice is that the number on the bottom always goes in front of your radical. That's because there's a proof in your book if you want to read it. I'll be like showing you guys. And the number on top always goes here. So that's like x to the 1. The m always goes there. I'll go through a couple examples to be a little clearer. So, my first example here. You can get that? We good? If I have 16 to the 1 over 4. Hey guys. I can rewrite that as the 4th root of 16. No, we don't have that. And then from there we can simplify. You can put it in your calculator, get an answer. If you would get 4, you get 1. So any other questions with this so far? Quite a few. Okay. Well. Okay. So we rewrite this as 2 root 25. Yeah. Then we have 2 root 5 times 5. And because there's a 2 here, we take out a pair of 2. So there's 1 pair of 5. Take out a 5. We're coming together slowly. Because it's square root, it's implied. So in a normal square root, exactly. There it is, yeah. You guys don't have root. But if it's like a cube root or a fourth root, you have to write the 3 or the 4. Okay? You guys ready for another example? Yeah. Yeah, I guess so. Okay. Okay, so our example here, negative 27 to the 1/3. When I rewrite this in radical form, I get the cube root of negative 27. Oh, God. I have negative 27 under. In brackets, out of brackets. Well, why is it bracket? I just put it in brackets. Okay. When I break negative 27 down, what do I get? I get the cube root of negative 3 times negative 3. Put them in brackets. You don't have to be in brackets. As long as you know it's negative 3 times negative 3 times negative 3. And because of the cube root, I want to take out a triplet, I guess. So here I have 3 negative 3's. So I take out negative 3. Why would I There's 3 negative 3's in negative 27. Yeah. I have 3, and then I take out 1. Because of the cube root, 1 comes out. Okay. Any questions on this? We'll get through a couple more examples here, guys. Okay? Yes. We'll get there. Okay. I just want to get through another example here. I have 100 to negative 1 over 2. The other thing, right? 1 over 100. All to the 1/2. All the way back here on the first page. Remember when we did this? The x to the negative 3 becomes 1 over x to the 3. We don't have that. That's the same thing that's going there. It's still an exponent. It's still an exponent. So, how would we rewrite this in radical form? Because it's not 2 times, it's 2 little much. So yeah, so when we do this, we look at the square root of 1. What's the square root of 1? 1. What's the square root of 10? 10. Or 100. 10. So there's our answer. Yeah. We'll get back here once we get to hard. Okay. All you did was you did square root of 100, right? So you did square root of 100, square root of 1. And you just one pair up. Yep. So that makes 10 times 10. That's what it is. Okay. Are you ready to move on? Yes. Okay. What if I have something like this? You guys are all going to hate my guts. Here? Because this was the same thing. I did skip a step, you're right. Right? And then I take the 10 out. Take the 1 out. We're cool? How'd you get that? There you go. Okay. 8. 8. 4 root 16 for the 3. Now, I'm going to do something to make this easier. This here, okay guys, listen up. Come on guys. This here is the same thing as that. Believe it or not, it is. Why is it 4? Why is it 4? Because we have a 4 on the bottom. You know why is it 4 in the bracket? Because it's in the root. No. This is the same. All I did was move the 3 outside the bracket. Okay? You can do that. That's why I moved it like this. So then you won't have such a huge number. What's the next step? The next step is we just take the 4th root of 16. Okay, what's your question, Pat? Hey, you guys gotta be quiet. 2 times 2. Okay, we did 16 before, right? And we got the 4th root 2 times 2 times 2 times 2. Still all to the 3. Right? There's 4 here. We take a 2 out. 2 cubed. And 2 cubed, with your calculator, 8 is 8. Yeah, once we get rid of the sign, wait, you have the 2's under the sign, but then once we go from this step to this step, you get rid of everything. So, you don't have to that nice to do. We can do it. What way we go? 25, we get 5. Bring down our cubes. 5 cubes. 125.